Okay, so this is problem 610. This is a bond price calculation. We need to understand what a bond price calculation actually is. What's what we're doing with the bond price calculation is we're present valuing the maturity value or par value or principal. Those all refer to the same thing. In this case, it's $1,000. So plus and then we're also present valuing the coupon payments. So we're going to use both the payment and the future value register for our cash flows. But so I've created the debt service schedule for this bond. So let me read the question, and then we'll talk more about the debt service schedule. The Treasury manufacturers issued a 10-year bond 6 years ago. So 10 minus 6 means there's 4 years remaining. The bond's maturity value is $1,000. The coupon interest rate is 6%. Interest is paid semi-annually. In the United States, 90-something% of fixed-rate bonds pay semi-annually. If you go to Europe, the bonds in Europe generally pay annually. And it's, I can't, maybe you could Google it and understand why, but anyway, it's just, seems to me it's just the convention, but I certainly haven't really looked into it. But anyway, so the bond's maturity value is $1,000 and interest rate is 6%. That's the coupon rate. And I don't understand why the textbook doesn't use that coupon or coupon rate. Interest is paid semi-annually. Investors require a 5% return to invest in similar bonds. What is the current market value of Tracer's bonds? So here's the cash flows that we're present valuing. So in the 8th period, so 4 years left, 4 times 2 periods per year, so 4 times 2 is 8. So in the 8th year, we're going to take the 8th period, not year, into the 4th year. 1,000 times the coupon rate, 6%, and then we divide it by 2 because it's semi-annual. So, and then that coupon payment is going to be made every period, beginning in the first period in 6 months from now. When we work these problems, we're assuming we're settling on an interest payment date. There is a bond function in your calculator that will, and in Excel, bond price, that will do calculations that aren't on an interest payment date, which, if you think about it, interest payment dates or coupon payment dates are only twice a year. So most bonds are probably traded between interest payment dates. And then we have to allow for the interest that has been earned or accrued up to that point. But we don't work those problems in this class. So anyway, we have the interest or the coupon payments. So, and then the total is the principal plus the interest. So, since we only have one principal payment, then we have a constant $30 coupon payment, and then in the last period we're going to receive both. So to calculate let me format this. So I'm going to use the coupon, and then I'll format IY as a percent. So just hit the comma. So that'll give me equals 4 years, and then semi-annual, so times 2. And then we do percent, and I'll make it 2 decimal places. Don't necessarily need to. Equals 3 divided by 2. No, it's not going to be. It's not going to like you can't, if you're not doing any operation, you can. Of course, that's not even right anyway. So here, 0.06 divided by 2 will give us 3%. So we're calculating PV. So if we were doing this in a calculator, it would be we would do compute PV. So our payment is 1,000 times 0.06, the coupon rate, divided by 2. Oh, I'm sorry, I didn't. I'm screwing up here. Or that's correct. So, and then the PV is the 1,000, and those are both positive because they would be receipts. The IY is the 5%. Sorry, not the 6. That's the required rate of return. Or in this case, we again the required rate of return is the yield to maturity. So it's what any professional would do, but academians are either idiots or they're trying to reinvent the world. So got my equal sign. So equals 0.05 divided by 2. So and then in this case it would be equals PV. So again, we've got the present value of a lump sum, and then we've got a present value of annuity. So PV. So our rate, the 2.5%, the number of periods, 8. And remember to hit a comma between each of them, and just you literally do it exactly the way it's shown here. The payment, go down, hit down arrow to get to there, and then because it's kind of hidden. So and then future value, we don't have to worry about type because it's payments are made at the end of the period, which is correct. And then PV, so $1,035.85. So it comes out as a negative. A lot of times what I'll do is just put a negative here, and then it comes out as a positive, and you would enter that on your exam as $1,035.85 with the commas and the decimal. So if I can use this information to calculate the yield to maturity, which I already have, and I know the yield to maturity is 5%. But if I didn't have the yield information, I use the equal rate function, and so my number of periods is 8. Then my payment is the $30, comma, future value, and then it does have a place for a guess, but that's unnecessary. And the important thing here, since we're doing semi-annual, to annualize it, we multiply it by 2. What did I? Oh, I left out the PV. Whoops. All right, so PV is would be minus the 1,035, and then future value is 1,000. Yeah, there we go, and now we multiply by 2. All right, so 0.05, 8%, 5%. So that'll be the majority of the time value money questions that you use for in this. You also calculate yield to call, which the key to calculating the call price, it would be the same. You need to calculate the number of periods to the call date, and then the call price is the future value. That's important to note.